is the third of 3 videos where I'm talking about the inverse trig parent functions in particular. And so you should watch video 1, you should watch video 2. I'm doing all 3 of them right back to back, and I think if you watch all 3 of them, you'll have a good understanding. But I do want to talk about making tangent of x become the inverse tangent of x, okay? Or we might say arctangent. Okay, so if you think about, oh, dang it, sorry. Okay, back to my calculator. Let's say I want to graph tangent of x. Well, let's change the window to just be the trig window. Sorry. Okay, so notice that if I have a particular y value, like if I try and take its inverse, I can sketch inverse. Well, you can't see it. Change that window from -10 to 10. Okay, so there are all of those trig. Now I have to sketch the inverse. So what in the world is going on? What it's showing us here is that it's taking the inverse of all of those. Well, the blue failed the horizontal line test, which means that the inverse, the green, will fail the vertical line test. And so that's not the inverse. But what we want to do, what we want to do is we want to take that tangent graph, and once again, you have to know the original stuff. Tangent, if we restrict it to just the one period around the origin, you may remember that this is not y. This is x equals pi over 2, and this is x equals negative pi over 2. We have the point 0, 0. We also have the point. The one that's easy to work with is the pi over 4. Tangent of pi over 4 is 1. And if you remember, tangent on my unit circle tells us the slope of that line because it's y over x. Hopefully that is something that you're familiar with. So like with pi over 4, this y value and this x value are the same, so its slope is 1. So there's that. We also have over here, we've got a point negative pi over 4, negative 1. Okay, so we've got those things, we've got these 2 asymptotes. So this actual graph repeats this over and over and over and over again forever, but we only want to have one piece so that we can find its inverse. So what we will do for the inverse, y equals inverse tangent of x, we're going to still have 0, 0. We're going to have, instead of an asymptote at x equals pi over 2, we now have an asymptote at y equals pi over 2. Instead of an asymptote at x equals negative pi over 2, we now have an asymptote of y equals negative pi, whatever that I just wrote. Okay, and then think about this. This is a positive and a positive, so even when I switch it, positive and a positive, even when I switch it, they're both positive, so I'm going to be growing this way. So somewhere over here, I'd have the point 1 pi over 4, because it was pi over 4, 1, we switch. So we're doing something like this, and then it kind of goes something like that. And so that's the inverse of tangents. That's arctangent's graph. Another thing to consider, so when we think unit circle with arctangent, notice, well, okay, the domain here is all real, and its range is going to go from negative pi over 2 to pi over 2, but you'll notice that unlike sine, it does not include these 2 values. So we're going to use those soft brackets here. Okay, so quick little refresher. When I'm thinking unit circle, and if I'm thinking y equals, or if I'm trying to figure out arc sine of something, okay, arc sine of whatever, I want to live in quadrant 1 in the positive direction and quadrant 4 this way. Okay, because arc sine has a range, or we restrict the domain of sine from negative pi over 2 to positive pi over 2. Okay, arc cosine, we're in quadrants 1 and 2, so going from 0 to pi, that's arc cosine is going to keep us in these 2 quadrants. I'm going to put an X or something. Okay, and then arctangent keeps us in a similar way to sine, except we can't have negative pi over 2 or pi over 2. So arctangent is going to go from negative pi over 2 to pi over 2. So like if I were to say, okay, what's arctangent of -1? Well, I have a slope of -1 down here, but I got to get there in the negative direction, so this would be equal to a negative pi over 4. Hope that's helpful. You're welcome.